In this video, we're going to get our DC motor actually spinning. And before we do that, we need to just do one more thing to set up our IDE to make life a little bit easier. So what I'm going to do is open up a new sketch by going File, New, okay, and closing out whatever sketches are open on my machine right now. And I'm going to come up here and go File, Preferences, and down here in the middle of the screen, we're going to see Display Line Numbers. Okay, that'll give you these nice grayed out numbers here on the left-hand side as a reference point when you're talking to myself or another student in this class about your code. You can actually say, please look at line blank and say a number, or your compiler will come back and give you a line number as a hint. So when you go to find an error, you can go back and fix it. So you need to turn this on at this point, please. So display line numbers, and I've increased my font size to 40 right here. So that's nice and clear on the recording. And if you want to make your font bigger or smaller, please do so. That's your own personal preference. I usually will code a smaller size so I can see more of my code at the same time. I'm going to hit OK and save that. Before I start talking about the setup over here, let's look at the basic setup of the code so we can bounce back and forth. In a previous video, we talked about a multi-line comment. So we're going to start by making a multi-line comment going ***, oops, so /*, and you'll notice that all of my code got grayed out. So I'm just going to jump down a line to line 2 and then go */. Okay, so an opening and a close tag for my multi-line comment. And I'm going to call this Tetrix Prism, okay, because we're dealing with the Tetrix Prism. And I'm going to jump down a line, add another star, just to, this is more of a preference here, you don't need it, but I'm going to add it in, space it out. And this is for Tetrix Prism, because I don't want to lose track of all my little code snippets. And this is going to be basic DC motor. Okay, so it's just the basics for operating our DC motor. What we need to do then is create some space on lines 4, 5, and 6, because we need to include 2 lines of code here to actually set up our Prism controller. The first one being our library inclusion. So we're going to go #include. We're going to use a triangle bracket or an angled bracket, and then we're going to type in Prism, all caps, so that it turns orange, and then go .h, and then close off our bracket. That will include the Prism library we downloaded a few videos ago. Next, we're going to enter again, and we're going to set up our actual object of type Prism. Okay, again, you'll see it's orange. The fact that Prism is orange here and our library is orange here is telling me that we're linking our objects and libraries through this library up here. Okay, so we're going to go Prism, and then in lowercase we're going to go Prism. Okay, so that's the way we're going to refer to this actual physical controller. Because this is a code statement, we have to end it with a semicolon. Okay, so we need that up there. And then finally, before we get going, we should add in a piece of code here on line 9 so that we can use this green button on our controller. And we do that by asking the program to access the Prism. Okay, all lowercase. We can see that it's matching up our variable name up here on line 6. Then we're going to use a dot to extend that object with a function and actually call a function on it. And in this case, we're going to call Prism begin. Okay, so Prism with a capital P and begin with a capital B. And this is an empty function. Okay, we're not going to pass in any arguments, so it's just 2 brackets. And then we're going to end it with a semicolon. That'll allow our code to access that green button. So at this point in time, I'm going to make this screen bigger, and we're going to talk about the quick setup here. We have our subassembly for our switch, which is good. We're going to move that over to the side and maybe use the battery to hold it against the Prism. Okay, so it's sort of out of our way. And we're going to take our DC motor subassembly that we built in a prior video. We're going to hook up our power. Okay, so we're going to take that, hook up our power, and then we're going to take our encoder and hook that up into the top. Please note I'm using motor 1 and encoder 1. And there's a lot of cords here. So the reason why I use this C channel upside down is so that I can sort of turn it, stick the cords underneath, and that'll sort of help to hold it down and out of the way. Okay, so that's not bad. I can leave it there, and then I have access to my power switch, I have access to my buttons to start and stop my program, and I can see my motor. And just to note at this point in time, I left the tape on so that when the motor turns, I can physically see is it going clockwise or counterclockwise when I'm at my keyboard. So at this point in time, I'm going to ask you to pause the video and open up your book to page 163. Okay, so when you open up your book to page 163, and I'll put a screenshot about this in the bottom, in the text here below this video, we can see that halfway down the page, there's a set DC motor power function. And it says set DC motor power sets the power level and direction of a Tetrix DC motor connected to the Prism DC motor ports. The power level is a range of 0 to 100, and the direction is set by the sign positive and negative. Okay, so that's very important. We looked at this in a prior course in grade 9 using positive and negative integers to control direction, and the value itself, 0 and 100, controlling the actual speed. So power level 0 equals stop or in coast mode for this robot, and power level 125 means stop in brake mode. So it'll actually apply some power to brake the motor. Okay, so it actually applies some counter friction. So in the middle here, we can see it says set motor power, motor number, and power. This is a function that takes two variables. Motor number is a variable, and power is a variable. We haven't looked a lot at this in previous courses, so this is going to be our first introduction truly into a multi-argument function. We can see that the motor number, its data type is an integer, and that the power is also an integer. Okay, so we're dealing with whole numbers, whether they're positive or negative. And that the data range for motor number is 1 or 2, which refers to motors number 1 and 2 here on my controller. And that the power is anywhere from negative 100 to 100, or a value of 125, which stands for brake. And then over here on the right, we can see that it gives some examples of how to use that function. So let's go ahead and try that in our loop. We'll use some delay statements and try it out and see what we can get our motor to do. So I guess the first thing we need to do is call our prism. So prism dot. Okay, so we're going to link to that controller. We're then going to call the function, and we're going to write it exactly as we see it on the page in that orange text, which is set in lowercase, capital M for motor, and then prism with a capital P. Power. Talking about the power of the motors. And then we're going to open and close our brackets and put a semicolon. This function, if I was to try to push it right now, would come back as an error because it is expecting 2 arguments. I already told you that I'm hooked up to motor number 1, okay, right here. So I'm going to go 1, and I'm going to go comma, okay, because we have to separate our arguments with a comma, and we're going to pass in the power level. Well, let's just pass in something nice and slow right now, maybe 25. There's no point in going full speed. We're just trying to make sure we understand how things work. So if I do that right now, my motor will just stay on consistently at a speed of 25. So let's go ahead and push that. Okay, you can verify it first if you want. I'm going to go ahead and push, and I'm going to pause the video, and when it's done, we'll come back. Alright, so it's done uploading. I forgot to actually select the port again, so I did put a little hopefully tag in there saying please remember to change your port. And if when I'm editing this video I forgot to, well, here's your notice. Please make sure you go back up and go Tools, Port, and make sure you select the proper COM port. I accidentally had switched USB ports because I have a lot of things plugged in, and I may have missed that prior to the pause. So our code is uploaded. I'm going to go ahead and hit this green button here, and my expectation when I look at my code is to not only when I hit Prism Begin, but I should immediately start seeing my motor turn at quarter speed. And because we have a positive value, I should see it turn clockwise. So it should turn this way. So the tape should come up and over. And it's good practice to make sure you understand what your code is doing before you hit play, so that you can debug your code on the fly if it's not working properly. So I'm going to hit green. As you can see, we're turning clockwise, which is great, at quarter speed. Okay, and it's a pretty nice consistent motion, that's really good. So I'm going to stop that and hit stop. And what I'd like to see is maybe have it turn a full rotation and then turn all the way back. And there's a few different ways we can do this. We're not going to deal with motor speed with the encoders quite yet. We'll try to do it through speed. So let's see if we can get it working just by trial and error with a delay statement. So remember, delay is a statement that takes a time value. Okay, so I'm going to give it half a second. And what it should do is pause the microcontroller and not let it process any more code until the delay is up, at which point in time on line 15 I can rewrite my prism statement on line 13. So prism dot set motor power, and I could say 1, but this time negative 25. Okay, so we'll get it to operate in the opposite direction, and I will have to add that delay statement once more, because if I don't, it will set the motor to go counterclockwise at quarter speed, but because we're at the end of our loop, it'll immediately jump back up to line 12 and start the loop again. So we would never actually see that. And maybe that's a good idea for you to try. Delete this delay statement, try the code, and verify that, you know what, my motor never does turn counterclockwise because I'm not giving it time to. Okay, so I'm going to go ahead and push this code, and I'm going to pause the video. My COM or communication port is already set from the last time I reset it, so we're good there, and I'll join you again here in a moment. Okay, our sketch is uploaded. We are ready to try it out. We can see it is done. It's finished uploading. So I'm going to go ahead and hit the green button here on my screen, and we're going to watch the motor. So we see it's going to go back and forth. And we can see that the 500 seconds, the 500 milliseconds is not getting really much more than, let's say, a third of a turn. So if I wanted a true full turn, and I'm going to give you an average or an estimate here that that's about a third of a turn. If you imagine like looking at it this way and imagining a circle, I'm getting about 1/3 of a rotation. So if I come in here and multiply this time statement by 3, I should get a full turn. So 500 times 3 is 1500. So we're just going to put that in here and see if that works. We're going to upload it to our robot again, our controller. Once it's done uploading, I'll hit start and we will check it out. Okay, so this is a very good practice to get into. Once you get something working, modify the values and see what it does. So I'm going to hit upload and I'll be back with you in a moment. Alright, we are done uploading, so I'm going to go ahead and hit the green start button here in a second. But just as a reminder, please get into the habit of looking at your program loop and understanding what it should do. So I should see my motor go clockwise, okay, on port number 1 for 1.5 seconds, and then it should switch directions and do that for another 1.5 seconds. And if we estimated things correctly on the last go, you should get a full turn. Okay, so I'm going to cheat a little bit here, get that tape to sort of line up flat so it's easier for me. I'm going to hit go, and let's see. Oh, there's a little bit too much. Okay, there's a little bit too much. I let it run there just to see if it would catch up. I wanted to observe the movement, and it did seem to always start restarting closer and closer this way. It was sort of starting to drift. And that may be because we were moving forward at a speed, and then it wasn't braking. It was just trying to go back, so it had to then try to counteract the force. So I think it was actually spending more time going forward than it was backwards. Something was happening there. We weren't getting a true rotation. And that's one of the limits of using the set motor power function. Okay, so go ahead, play around with this function, change the speeds, change the delay times, see what you can get it doing, and we'll see you in the next video.